Hi everyone, my name is Teddy Aryono. I'm a developer specialist solution architect here with AWS, and welcome to AWS Builders Online Series. If you're just getting started with AWS and you're trying to decide the right strategy for your deployment, you're in the right place. We're going to talk about how to choose the right modern deployment strategy, and we're going to cover all approaches of different deployment mechanism and options you have on AWS, regardless of the compute options that your application will be deployed to. First of all, I'll cover the CI/CD refresher just to make sure you get the baseline terminology and we are on the same page on CI/CD. Then, I'm going to describe some overall tenets, goals, and foundational things that you should be aware of when you're defining your deployment strategy. Then, when you choose any deployment strategy, there are some kind of core options that you have to choose between. I'm calling this as modern deployment consideration, and I'm going to talk through this. Your preference in those considerations may help you choose which options is right for you. Then, I'm going to go through specific actual deployment options available on the AWS platform and some details about how to implement each of them. Before we wrap up together, I'll give you a quick demo on how to implement one of the deployment options that we've talked about. Finally, we'll conclude our talk and hopefully you'll know which deployment mechanism might be the best fit for you. So let's jump into CI/CD refresher. We've broken down the software development lifecycle into these 4 stages: source, build, test, and production. In the source stage, application code gets checked in into the repository, and typically code review process also happening in this stage, but nothing's running yet in this stage. Then, the build process is taking that code and compiling it, running some automated unit tests, making sure that the code style meets the standard, making sure that the code coverage from a test perspective is meeting policies that have been set before, and the code that's been written is compiled and packaged into some type of deployable unit. You've got set of artifacts that have been compiled together and able to be deployed now. Then you enter test stage where you take that deployable artifacts and you integrate it into an environment. Maybe there's other services that are going to integrate with this deployable unit you've just deployed, and you need to make sure those integration between them are working. You make sure any dependencies you have or things that depends on you are happy with the changes that have been made to these new deployable artifacts. You go through some different testing to give your team and your business confidence that when it gets deployed into the production environment, things are going to be successful and your customers are also happy. And finally, once you've been satisfied with all of the testing and you've also got the confidence you require, then you're going to take that deployable unit and put it into a production environment where your customers can now access it. Your business is now running on top of it. Then, continually, you're going to monitor the success of that code. You collect data for various metrics. You gather insights about the way the application is behaving or the way your users are interacting with it. Each one of these stages is all about creating feedback loops in the development lifecycle so that you are able to catch problems and fix them as early as possible. AWS has various offerings of services that provide capabilities for each one of those individual stages in our development lifecycle, starting from code repositories within our code commit service and the cloud-based IDE to help you develop code that's going to be contributed there on our Cloud9 service, all the way through the actual mechanism of deployment and subsequent monitoring inside of your production environment or any other environment. We are not going to go through all of them today, but just so you know that for each one of those stages in the SDLC, you've got native capabilities on AWS to bring additional automation, enhancement, better visibility, and transparency throughout your application lifecycle. Today, since we're talking about deployment, the service we are mostly going to focus is AWS Code Deploy. So AWS Code Deploy is the service that helps take those deployable artifacts and instrument those changes to be taken place in a running environment. Whether your application is running on a single server or tens of thousands of servers, it's a fully scalable service and it's able to support your application that have been deployed on these various compute types that exist. Code Deploy provides programmatic mechanism to make deployment safe and automated regardless of the compute types are, whether your application are running in a virtual machines, containers, or serverless in AWS Lambda. In Code Deploy, you've got different hooks that revert to the series of events that describes how a deployment is accomplished. It allows you to control or perform actions on different stages of your deployment. Code Deploy monitors the deployment process and roll it back when a deployment fails or when a monitoring threshold you specify is met. Now, let's talk about general tenets that you should be thinking about when you're designing a modern deployment strategy. It's not just about automating deployment for the sake of automation itself, but there's things you should be striving for from business or team perspective to make sure that those deployments are successful and safe. These are the tenets I want to highlight that I think are true for every modern deployment that exists today. These tenets are pretty universal and not going to be unique to specific application. It should be a goal within modern deployment that there is not going to be any disruption to the business. Your deployment shouldn't cause orders to stop on your website. It shouldn't prevent your website visitors to be able to utilize features that is important for the revenue generation. So making sure there is no disruption is clearly priority number one. Any type of modern deployment that requires downtime or business disruption is clearly not going to be as good as it could be. Next, making sure they are iterative and frequent. The more you are able to reduce the risk of a deployment by making changes smaller, the more you are able to ensure less bugs exist, and you are able to have a narrow scope of investigation for the changes that occur. And by making them iterative, you're able to make them more frequent because they're able to be done in smaller batches. Quicker development lifecycle that result in deployment to production means you can deliver features for your business faster. So, striving to be iterative and frequent in your deployment is important. One of the things that enables that is having hardened version. For example, specific version of container image or a commit against a code repository. You can treat them not only as a version on their own, but as a holistic version of your application. So that if you need to do a rollback in the future or go back to some other prior state, you can do that by referring to specific version of your application. You know exactly what dependencies that you have or things that depend on you. You're speaking in the same terms of what those versions mean. You talk about a holistic version of an application deployment so that all of those dependencies they are in are following the same type of version. For example, if I'm on version 2 today and I need to roll back to version 1.9, then version 1.9 brings not only the version of my code that's running, but any other dependencies that might have had within the other service I'm depending on. Then automation. I believe I don't need to explain much more about automation and how this deployment should be automated. No operations or development team needs to take care for deployment while it's occurring. So making sure they are automated is really important. And then auditability, something that often gets neglected. It's not just important during audit in security sense so that you can see who made changes and when they occurred, but also in the operational sense so that you know when a bug occurred and what's causing it within an environment. You can preserve a good solid audit trail that you can analyze later. Your operational logging tools should have the ability to dive in really fast in your operational logs and understand where errors might have begun within an environment, which deployment date might be associated with. So these are the deployment tenets we are talking about. They're kind of all fit into each other, but the goal is to have a nice, clean, and safe automated deployment so that you can iterate fast with confidence and deployment shouldn't disrupt the business and you are not requiring a lot of manual work in order to achieve that so that you can focus more on the business and innovate faster. Now, let's talk about deployment consideration. Like I said before, regardless of which deployment options you choose, There's always some kind of core decisions you'll be making about how to treat your infrastructure during deployment. The first thing I'm going to talk is about metrics, tests, and alarms. No matter which option you choose, this is the bare bones, and it should be considered as prerequisite to having a good modern deployment approach. You can trust your deployments if your metrics give you visibility into what the real health of your application is. You only have confidence that your deployment is going to be successful if your test suites are covering enough in terms of functionality to know that you're checking the right things before your customers are the real test cases. Finally, alarms exist so that when those deployments potentially go wrong, then your metrics will show data that maybe are not what they should be. Your alarms will catch those things at the right threshold and notify deployment mechanism that rollback should occur quickly and safely before it goes to your customers. We provide you a lot of these things out of the box. Almost all of our services have various built-in metrics that are relevant for your operation, and it's really easy to take advantage of them. But the idea is to not only depend on this. Well, obviously it's important to use them, but you know your business and your application context best. There are always metrics that you have to gather by yourself related to your own application. For example, things like how many users are visiting specific page within your application, or how many errors are being generated by a specific line of code within your application. Those are types of things that live inside your application. You should generate your own metrics, create your own tests, and create your own alarms. So regardless of what deployment methodology you end up choosing, these are the bare bones requirements. The next consideration that will help you to decide which deployment option is best for you is whether you want to pursue mutable or immutable infrastructure. There's been a big push among a lot of our customers for immutable infrastructure because there's a lot of benefits for it. But there might be good reasons why immutable infrastructure doesn't make sense for your application. There is some pros and cons for both. Immutable infrastructure means that after a deployment has occurred, a piece of infrastructure has been created and is active within the environment. Nothing can change it again. No human access to the operating system, and no configuration changes can happen. Once that piece of infrastructure out and open in the environment and serving its purpose in the architecture, it cannot change anymore. Nothing can access it and nothing can change it. Whereas mutable infrastructure is obviously the inverse of that. In a running server in an environment, you still have the ability to access that server and change something in place if you need to. Some pros and cons highlighted here. On the mutable infrastructure side, if your operational processes still need to do some hot fixes, you are able to do it quickly here. You can have some folks jump into an active server, maybe troubleshooting something or deploying configuration changes to the active environment. But for whatever reason, of course, it's a pretty dangerous thing to do from a security perspective. Also, because you're allowing changes to occur outside of the automation, it could make any investigation more complex. Whereas on the immutable infrastructure side, you can have a lot of confidence that this piece of infrastructure hasn't changed. All of those things are baked into it, and there hasn't been any additional changes that have occurred to it, which is able to simplify identifying problems or root causes when they may have started occurring within your environment. Other thing I'd like to highlight here is the cost difference. If you deploy very frequently or you have a reason to have a very large amount of infrastructure running alongside each other during a deployment, running immutable infrastructure could be cost prohibitive. Whereas mutable infrastructure, because you are able to make those changes in place, it might be more cost effective for the way your application deployments occur. Okay, so let's move forward and talk about what the actual options of modern deployment might be. So the first one I'm going to highlight here is called rolling or linear deployment. I've got a running application and I'm going to incrementally increase the percentage of the environment that's running the new application in comparison to the old application. The reason why folks like this is it adds risk incrementally. We're going to be deploying to small units of infrastructure one by one. It limits how many changes are happening concurrently. If something goes wrong, I can detect it pretty quickly and roll back without the entire environment having been changed, and lets me reuse the infrastructure that's already there in the environment. Cons of this is sometimes if you have a very large number of server or application components and you're a very risk-averse organization, it might take a really long time for a linear deployment to complete. If you want to deploy to over 100 servers and you deploy to one server at a time, it's going to take several minutes for that deployment to complete. Those things can add up pretty quickly, and it could be a really long time before the deployment is considered successful. On the same tone, the rollback can take just as long as the deployment. You can obviously change your strategy of how quickly you might want to roll back, but there might be reasons why you cannot. Maybe you're tightly managing how connections to dependencies work, and you need to make sure that it's a nice gradual rolling change rather than opening a floodgate. So in those rollback cases, it might lead to a really long rollback times. And this idea of heterogeneous environment can be a complex thing to manage and deal with as well. In the midst of a deployment, you have a single environment that is running multiple versions of your application. They could be interacting with a single set of dependencies and creating operational investigation scenario where all things are maybe happening with how state is being stored or how object definitions are changing. Your various dependencies need to be aware that multiple versions of application running at the same time. Even worse, how traffic gets routed to each version will just add an extra layer of complexity. So, if you think that this is the right type of approach for you, there's a couple different ways you're going to implement it. For EC2 service, if you're using Code Deploy as your deployment tool, I've got snippets here with highlighted line where the various properties associated with the configuration of Code Deploy relates to choosing a linear rolling deployment. The idea here is basically minimum healthy hosts. I'm informing Code Deploy that I always want to make sure that 90% of my hosts are healthy. Healthy means they're able to actively serve requests. Otherwise, if they are in the middle of a deployment, we can consider them unhealthy because they're not able to actively serve requests. So you're able to define what's the minimum percent of your hosts that are still stable and healthy and serving traffic on the old version or the new version, and what percent therefore is able to be taken down to have a deployment occur against that piece of infrastructure. You can specify percentage between 0 and 100, and it will define how many hosts are able to be taken offline and how quickly that rolling deployment occurs. The second box I have below is related to load balance application, where Code Deploy will help take control of registering and deregistering instances from their load balancer. Then, on the right side of the slide, you can actually use autoscaling as a deployment mechanism as well. When you use autoscaling, Code Deploy will automatically roll a new set of server into a new autoscaling group at the rate which you are defining what the batch size of that rolling update should be. What type of cooldown and pause time exists between updates that are occurring within the group, so you can use autoscaling even to achieve the rolling deployment type within EC2. If you're using ECS for container-based application, you have a property called deployment configuration, where similar to the Code Deploy option within EC2. You can specify maximum and minimum percentage of healthy containers that are running as part of your service. In this case, I want to make sure that my desired number of tasks is always running at 100% and never less, so that I can satisfy the traffic demand I expect. But I'm willing to go over that amount by 10% or up to 110%, so that ECS will be introducing another 10% of the new version of that image of my containers into the service in a rolling way. Then, if you're doing rolling or linear deployment in serverless application, there is property available for your Lambda function as well, called deployment preference, where you define the type. There is a specific name type of deployment preference available to you by the Lambda service. One of them is a linear option where you define the percentage of which you'd like that linear deployment to occur over what period of time. In serverless deployments using Lambda, it's all based on alias of how traffic gets shifted. In this case, I want an additional 10% of traffic shifted to the new version or the new alias of my Lambda function every 3 minutes. So 0 to 10% in the first 3 minutes, then 10 to 20% in the next 3 minutes, so on and so forth until you reach 100%. So those are rolling or linear deployment for all compute options of virtual machines or EC2 instances, containers, and serverless. The next deployment option is blue-green deployment. I'll demo this deployment option later on. So blue-green is about provisioning a net new infrastructure set that's running the new version of your application. That's going to exist alongside the old version of your application. So I have here a blue version starting on the left side. That arrow coming from above is representing incoming requests to my application. I'm going to provision a green version while the blue version is receiving traffic. There's going to be a period of time where both of them are running simultaneously, and I'm able to cordon off a small percentage of traffic to send requests to that green version, or even it's not a live traffic, just a test traffic, so that we're able to get more confidence that this newly provisioned green environment is behaving healthily. Once we're confident, we can now shift the blue traffic to green. You can see that the blue stack remains available for some period of time, so that if we decide to roll back, all we need to do is shift request traffic back to that blue stack that's still up and running. It's going to give you a really quick rollback mechanism. The traffic shift usually is done through DNS or other similar mechanism like service discovery if you're running microservices environment. But if everything went smoothly, we will spin the blue stack down and we're just left with the new green version of the application. Pros by taking this approach is I'm able to keep my environment consistent as it travels through my various lifecycle environment. I always produce a new full set of infrastructure, and I can be very confident that the entire set of infrastructure is going to satisfy any test that I run against it. It's going to be against the same environment that my customers are having their requests routed to. There are no in-place changes that are occurring that I have to worry about. In the blue-green deployment, I always get a fresh set of infrastructure. The downside is, because you are going to operate these multiple environments for some periods of time, you're going to potentially incur more cost depending on how long they stay up and running, and also how large the application environment is. The other downside is, applying hotfixes can be a really difficult task and potentially slow. If you're running immutable infrastructure, you have to bring up your increment of your application version to be deployed in the whole new set of infrastructure. You have to start all over again from provisioning infrastructure, and that can often take a lot of more time than just making a quick code change. Last but not least, you have to think about cold infrastructure when it receives requests. If you're dependent on things like in-memory caching or session state within your servers, and those things get populated as requests rolling, then it might impact performance for some period of time because the green version hasn't received any request yet. So if the blue-green deployment is the right option for you, how do you implement it? Very similar property is being highlighted here. In the ECS, you've got the option of having a built-in blue-green deployment capability where you're going to define a new set of container images for your task. When that deployment occurs, ECS will provision the new blue-green environment, but linearly shift traffic to the green set of images. So even though it's called linear configuration, it's going to provision that new set of images. There is no in-place deployment within the container image. So it's going to be fresh container image that's been deployed. I put it here, blue-green category, but you're able to kind of linearly shift that traffic over to that green image over time. And then on Lambda, the same type of idea as before in ECS. You're not making code changes in Lambda function itself. It's always a new Lambda function alias that's serving traffic. So the same idea, linear shift of traffic. With EC2 instance, it's required to implement fully fresh environment. You have to provision a new set of EC2 instance that will be our green environment. You will do blue-green deployment mechanism through something like DNS or service discovery. The last option I'm going to highlight here is canary or one-box deployment. This is the ability to change the smallest unit of infrastructure possible within your environment. Be confident that one unit of infrastructure is behaving healthy and then flip the rest of the application to the new version. You're able to minimize deployment risk by focusing on that tiny portion of your environment. It can also allow you to experiment on the new feature like A/B testing. Some cons of the canary approach: if you're going to create one box or canary environment that represent your application, you're going to have a new environment that may be serving production traffic as part of your application. So just like the deployment itself, a rollback is now going to be multi-stage. You've got a brand new type of production environment that lives on its own that you're deploying independently. So you need to be aware that additional staging that's going to come into play as you're going through your deployment steps, and that it might be bring additional complexity to the idea that these two environments will be serving production traffic and need to be kept in sync. So how you implement canary or one-box deployment on EC2 is similar as before. You're going to need to create a new environment which is required for EC2, but you always have the ability to create that new environment with ECS and Lambda as well. You create another name environment for your containers or Lambda function. I've got properties to do the canary type of deployment where 10% of my new container image is going to serve traffic before the other 90% of the traffic is also shifted there. Similarly with Lambda, where I shift 10% of the traffic over to my new alias. After 10 minutes is up, the other 90% is going to immediately shift over to the new function alias. So let's jump into a quick demo.
So we have a very simple website here, and we will update this page by appending text 2021. Everything in here is static, but at the very bottom is actually dynamic values. We will retrieve these values using AWS SDK and we'll display it here. We will retrieve code deploy application name, code deploy deployment group, and all EC2 instances associated with our autoscaling group. Then I'll walk you through the application code that I've prepared here. So this is the code for the page that you saw earlier. I will add text 2021 right after this text. The rest of the file should be the same, except at the very bottom, we'll retrieve the value that we're going to show at the bottom of the page. In here, we will retrieve a code deploy application name, code deploy deployment group, so on and so forth. Then, in the root of our project, we'll also have a file called buildspec.yaml, where this file is a collection of build commands and related settings in YAML format that code build uses to run a build. There are some sections in this file. The first section is phases, consists of install and build. So install represents the commands that code build runs during installation, and also runtime version here. In this case, we will use Coreto 8. The next section is build commands, where we can list our command that code build will run during deployment. In this case, we'll run maven install. The next section is artifacts, where it represents the location that contain the build output artifacts in the build environment. In this case, we have the war file and these two items, appspec.yaml and scripts directory, that will be used by a code deploy during deployment. Then the next file is appspec.yaml, where this is a YAML formatted or JSON formatted file used by code deploy to manage a deployment. Again, there are some sections here. The first section is version. This section specifies the version of the appspec file. It is reserved by code deploy for future use. Then operating system OS. This section specifies the operating system value of the instance to which you deploy. We can specify either Linux or Windows for this section. The next section is files. This section specifies the names of files that should be copied to the instance during the deployment's install event. Then this is hook section. This section specifies scripts to run at specific deployment lifecycle during the deployment. In this case, we have 4 events specified. The first event is application stop. You can specify scripts for this event to gracefully stop the application or remove currently installed package in preparation for a deployment. In this case, we're going to run stop application, which located in our scripts directory. The next event is before install. You can use this deployment lifecycle event for pre-install task. In this case, we are going to run install dependencies script. Then the third event is application start. You typically use this deployment lifecycle event to restart services that were stopped during application stop. In this case, we are going to run these two scripts here. And the last event is validate service, where it's used to verify the deployment was completed successfully. Then this is our stop application script, where we are going to stop our Tomcat application server. Our next script is install dependencies. So as the name reflected, here we just checking if we've had Tomcat installed, maybe clear install directory, installing a Tomcat, so on and so forth. Then in this script, we are setting variables that our application depends on. We've got application name, code deploy group name, and also deployment ID. We are going to display these values in the bottom of our page. Then this is our start application script. What we are going to do here is we will copy our WAR file to our instances. We are also starting our Tomcat server. And last but not least, we have got basic health check. We are using CURL to hit our localhost endpoint. If we get 200 as the response, we can consider our instances as healthy. All the code that I've just mentioned is hosted in AWS Code Commit. So Code Commit is a fully managed source control service that hosts a secure Git-based repository, so that you don't need to operate your own source control system or worry about scaling its infrastructure. You can use Code Commit to securely store anything from source code to binary. Then I'll show you the code build project here. So code build will help us to do automated build for our deployment pipeline. Let's see our build details. I've set demo app as the build project name. So in the build details, we can see the overview of our project configuration. I've set AWS Code Commit as the source provider with demo app as the repository. Then we've got our build environment, which represent a combination of operating system, programming language runtime, and tools that a code build use to run a build. In this case, I pick this image as my build environment. For build spec, we're going to use the build spec file within our project in the root of our project. Then this is the artifact section, which represents the location that contain the build output artifacts in the build environment. I'm going to put the output in this S3 bucket that I've prepared beforehand, and the output format will be zip. And I've also enabled a code build log. So the next thing I've also prepared here is a code deploy application and deployment group. I name it a demo app, and deployment type is set to blue-green, and also I've enabled the rollback functionality. Our code deploy will deploy to our EC2 instance. See more detailed configuration in here. Again, demo app as my application name, and also EC2 as my target deployment. Then deployment group name is also demo app. Then we have also a service role here. So service role is the one who's gonna allow code deploy to access our target instances. Then our deployment type is obviously blue-green. And then for our environment configuration, we're going to use auto scaling group. I've prepared one earlier, so let's take a look for a second here. And here it is. So auto scaling group is actually a collection of Amazon EC2 instance that are treated as a logical grouping for the purpose of automatic scaling and also management. And then for deployment setting, I choose to reroute the traffic immediately. Actually, I've got option here where I can trigger the traffic rerouting manually. So I can set how long the duration I have to trigger it. And the next option is whether your blue environment is terminated after the deployment completed successfully, and how long does a code deploy need to wait before termination. But we've got also option to keep the blue environment running, and you terminate it manually later on. So I think I'm good with this option for now. And for deployment configuration, I choose one at a time. So I've got 3 instances in my auto scaling group. And as the name suggests, code deploy will deploy the application revision to only one instance at a time. We can choose other option, or we can create our own deployment configuration by specifying the minimum number of healthy EC2 instances. Then since this is a load balance application, I choose this option. I've also prepared a target group beforehand. And so the next available option is alarm. So I define an alarm here. So if my fleet is serving more than 1,000 requests per second in 1 minute, I consider to postpone my deployment. So the alarm threshold is met and code deploy stops the deployment. And lastly, I enable rollback. So either when deployment fails or when alarm threshold are met. Then every stage in our deployment pipeline, which is source, build, and also deploy, will be orchestrated here by AWS Code Pipeline. So I name the pipeline as a demo app. Basically, AWS Code Pipeline is a fully managed continuous delivery service that helps you to automate your release pipeline. So now we are going to make a small change in our code. Here I add the text 2021 right after this text. So save, then we're gonna add and commit our change. Then push to our code commit. So then after we push the code, automatically our code pipeline is triggered to do a deployment. We can see that our source stage is in progress. Then after source, our build process starts. We can see the build log. We can hit this tail logs button to kind of follow our build log. So our current page now is built. We have to wait until it's completed before proceed to the next stage. Then now our build status is completed. Then we can see that our pipeline is now in the deploy stage. We can click this link to go to code deploy deployment detail page. Now code deploy is provisioning our replacement instance, which is our green environment. So code deploy is now spinning up 3 new instances as our new set of infrastructure. Then it will install our new application, then reroute the traffic, and finally terminate our old set of infrastructure, which is our blue environment. Then we can see here that our first step is completed, meaning we now have 3 new instances already provisioned. We can quickly jump into our EC2 console, go to instances, and we now have 6 instances. 3 instances are our old or blue environment, and the rest are our new environment, which is our green environment. And now our application is already installed in 1 out of 3 of our new instance. Actually, we can also see the detailed progress down below. As you can see, we have 3 original instance, blue, and 3 replacement instance, which is green. Remember that we are using one at a time as our deployment configuration. So a code deploy will deploy the application revision to only one instance at a time. So now our 3 new instances already updated. We can also see down below that our new instance is allowing traffic. This traffic shifting progress is also reflected in this right pane. Now, as you can see, one of our replacement instance is now serving traffic. Then now 2 out of 3 is serving traffic. Then now all of our replacement instance is receiving traffic. As you can see, the progress indicated here is 50% because we still have a process for our old instances to block traffic. Now you can see that we only have one old instance left, which still can receive traffic. Traffic to the other 2 is already blocked. Then now we can see we have no old instance left to receive traffic, and all traffic is already shifted into this through 3 new instance or our green environment. So now the termination process is finished. We have no old instances left. All of them are terminated. Finally, we can go back to our website, hit refresh, and now we can see our website is updated. Our deployment is completed successfully.
I've walked you through the different options available and some details of how to implement them. So let's wrap it up. How do you choose between them? Step 1, make sure your metrics, tests, and alarms are in place. The second step is to embracing automation. The core of all these options is that it should be automated. And the third is, whichever option you choose, start small and be iterative. Your deployment processes might be another piece of software. You don't need to solve all of your deployment requirements right from the beginning. Think about ways in which your deployment can be mature over time in an iterative way, just like you build an application changes into the actual application that's being deployed to. Finally, think about which downside that might be the most impactful related to your operational culture. That might help you choose which type of application deployment methodology will suit you best and avoid those downsides. Accelerate your cloud journey by checking out the featured courses to build your cloud skills on AWS by visiting these links. Or you can visit aws.amazon.com/training to explore over 550 free digital training courses. Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take time to fill out the survey and let us know what you think.